Alright, in this lesson we're going to look at pedigrees, and the pedigree is defined for you right here. A pedigree is basically just a family tree. It's not a complicated thing to learn. What you do need to know is there are some symbols that get used on pedigrees, and so you have to kind of know what that is, what those symbols mean. The first of those is a square, and a square means that the individual is male. Okay, so a square is used to represent a male in a pedigree. A circle is used to represent a female. Okay? If that circle or square is shaded in, it means they have the trait. So they're affected by it. If the square or circle is half shaded, then that means they are a carrier. Okay, so, and that's carrier in the truest sense of the word. In other words, they're not demonstrating that they have the trait, but they do have it in their genotype, which means they can pass it to their offspring. Another symbol you'll see is this one where you have a circle and a square that are connected. That's a mating pair. Okay, that's a mating pair. And the reason why we say mating pair is because pedigrees can be made for any organism, not just people. So it doesn't necessarily mean married, it just means they're mating and having offspring. You could do pedigrees for bunny rabbits or horses or even plants if you wanted to. Okay, so that's why we call that mating pair. And then finally, when you have a situation like this where dropping from the mating pair you have this line, and then you have squares or circles on the other side, that's the offspring of the mating pair. I'm going to run out of room, but that's the offspring. Alright, so let's look at the three scenarios that you're likely to see on a pedigree. This is a pedigree, and typically some features of pedigrees that you need to pay attention to are the fact that they're split up by generations, okay, and the generations are generally numbered by Roman numerals. So this is generation 1 at the top, 2 right below it, 3, and then 4. Okay, so we've got a 4-generation pedigree here. And what a geneticist does is uses these pedigrees to determine how a trait is passing and what kind of trait you're dealing with in a family. So if this family went to a geneticist and wanted to know why it is that they have this trait in their family, a geneticist would be able to look at this and tell several different things. The first thing the geneticist would notice is that this particular trait is rare. It's showing up in generation 1 right here, and then it shows up again in generation 4. It's skipping generations. The other thing the geneticist is going to notice is that females and males don't seem to be more affected than one or the other does not seem to be more affected. So both of those things indicate that this trait is autosomal, in other words, not sex-linked, okay, because you've got males and females roughly equally impacted, so it's autosomal and not sex-linked, okay, and that's what autosomal means. And because it's rare and skipping generations, it's also recessive. So this is what an autosomal recessive trait looks like. Now, on the EOC then, what you're going to be expected to do is take this and say, okay, if this is an autosomal recessive, this person's genotype is a, and then this person is a, and you're going to be expected to go and figure out what everybody else is. Well, chances are this person had to be a carrier, right? Because, excuse me, here, let me try the pointer. This person right here has to be a carrier, right? Because somehow it got passed through that line to end up in this 4th generation, right? So it's kind of like a logic puzzle. You go back and you figure out, okay, so that one must be a carrier. You know, we don't know what the other allele is here. We know that this individual is dominant. We don't know what the other allele is. Oh, sorry, we do know what the other allele is. Both of these have to be carriers because the mom here only had little a's to give them. So everybody here is a carrier. And we know that this person must be a carrier. We don't know what this one is. We don't know what this one is. And we don't know what this one is. Okay? But we do know that because of the way that this passed, this little a trait had to be passed down through the family line to get little a, little a, little a, little a. Oh, sorry, and we do know this person is a carrier as well, right? Because the only way to get 2 little a's out of the offspring here in the 4th generation is if these individuals are both carriers. Okay, so that's how recessive looks. Alright, so this is another scenario that you're likely to see on a pedigree. And again, you can see the generations labeled for you on your pedigree. You can also notice that often they number individuals on a pedigree, so starting from left to right, 1, 2, 3, 4, 5. And they'll do that so that when you're talking about a pedigree, you can talk about the individuals on it. So a geneticist would look at this pedigree and say, well, you've got a situation where males seem to be impacted and not females. And in cases like that, where males are more likely to be impacted, we'd say that this is sex-linked. Okay, so this is sex-linked. And because it happens to be rare, this is also recessive. And again, you would be expected to know that this is X little a y, right? You would be able to do that. Again, anybody on here that's got it is X little a y. You would be able to go back and say, okay, she must be a carrier X big A, X little a, right? Because that's how she passed this to her son, and so on. So you can label the pedigree as you need to. Alright, the last scenario is this one here, and again, a geneticist looks at this and says, okay, this is a trait that's showing up in every generation. Okay, so every generation has somebody. It's not skipping. It doesn't appear to be all that rare. So not rare typically means dominant. Okay. Also, notice you have 1, 2, 3 females and 1, 2, 3 males that are impacted. So one gender is not more impacted than the other, so this is autosomal. Okay. Notice also on these pedigrees, carriers are not necessarily shown for you. Okay. On none of these pedigrees that I've shown you has somebody actually half-shaded the pedigree. You would go back and do that later on. Okay, so you would actually take the pedigree and look at the half shade, fill in the half shades yourself as you're doing the genotypes. The thing is, with autosomal dominance, will you ever have a half-shaded individual? Well, the answer is no, right? Because you can't carry a dominant trait. If you have the dominant trait in your genotype, i.e. you have a big A, then you're going to express that big A. You're not going to be a carrier of it. It can't hide in your genotype like an autosomal recessive. So on an autosomal dominant pedigree, you'd never have any half-shaded circles. I can't guarantee that the EOC is always going to half-shade carriers for you. You might have to figure it out for yourself. You guys are going to do a little practice with this, and hopefully that will be really clear to you.